Case study: AI in cybersecurity, enhancing fraud detection, threat prevention, and user authentication. Artificial intelligence is fundamentally reshaping the landscape of cybersecurity, providing cutting-edge solutions to address increasingly complex and sophisticated cyber threats. In an enterprise striving to safeguard its digital assets, AI's capability to analyze massive datasets, identify anomalies, and predict potential threats has become a game-changer. This narrative delves into several real-world applications of AI in cybersecurity, highlighting how various organizations have leveraged AI to enhance their security protocols. A financial institution, JP Chase, found itself grappling with the daunting task of examining vast volumes of legal documents for potential fraud. Traditional methods, which relied heavily on manual reviews, were not only time-consuming but also prone to errors. The bank decided to employ an AI system named Coin to streamline this process. Coin utilizes natural language processing and machine learning to sift through millions of documents in seconds, identifying inconsistencies and potential fraud indicators. What factors contribute to the effectiveness of AI-driven fraud detection systems like Coin? The AI system's ability to rapidly process and analyze large datasets, combined with its capacity to learn from each document it reviews, makes it highly effective. According to Bose and Lung, the implementation of Coin significantly reduced the time and cost associated with manual document reviews, while also enhancing the accuracy of fraud detection. In another scenario, Darktrace, a cybersecurity firm, has developed an AI-driven platform called the Enterprise Immune System. This system mimics the human immune system by learning the normal patterns of life within a network and detecting deviations that may signal potential threats. During a routine network analysis at a major technology company, the Enterprise Immune System detected unusual activity originating from an employee's device. Upon further investigation, it was revealed that the device had been compromised by a previously unknown malware. How does AI improve the speed and accuracy of threat detection compared to traditional methods? Traditional cybersecurity systems often struggle to keep pace with the volume and complexity of data, whereas AI systems like Darktrace's platform can continuously learn and adapt to new threats in real time. Phishing attacks remain a persistent threat, tricking individuals into divulging sensitive information. Google's Safe Browsing initiative employs AI to combat these attacks effectively. By analyzing vast datasets of phishing and non-phishing websites, the AI system can discern patterns and identify malicious sites accurately. A small online retail company experienced a significant reduction in successful phishing attacks after integrating Google's AI-driven phishing detection system. What makes AI-based phishing detection more effective than traditional methods? The traditional methods, which rely on blacklists and heuristic rules, are often circumvented by sophisticated attackers. In contrast, AI-based systems can analyze URL structures, website content, and user behavior to detect and block phishing attempts more accurately. A study by Ontario et al. Revealed that Google's AI system reduced successful phishing attacks by over 90%. Cylance, a cybersecurity firm, has pioneered the use of predictive analytics to prevent malware infections. Its AI platform, Cylance Protect, employs machine learning algorithms to analyze malware characteristics and predict their behavior. A global manufacturing company struggling with frequent malware infections adopted Cylance Protect. The AI system successfully predicted and blocked potential malware threats before they could execute, significantly reducing the company's vulnerability to cyber attacks. How do predictive analytics enhance proactive defense mechanisms in cybersecurity? Predictive analytics use historical data to forecast future threats, enabling organizations to take preemptive actions. Cylance's study demonstrated that their AI-driven approach could prevent 99% of malware infections, compared to a 50% success rate for traditional antivirus solutions. The banking sector has also seen remarkable improvements in user authentication processes through AI. Traditional authentication methods, such as passwords and security questions, are increasingly vulnerable to attacks. To address this, a leading bank implemented AI-driven biometric authentication systems, focusing on facial recognition technology. This new system, akin to Apple's Face ID, analyzes unique physiological characteristics to verify identities. Consequently, the bank reported a significant decrease in unauthorized access cases. What advantages do AI-driven biometric authentication systems offer over traditional methods? These systems provide a higher level of security by analyzing unique physiological and behavioral traits, making it much harder for attackers to replicate or bypass. According to Apple, the probability of a random person unlocking an iPhone using Face ID is approximately 1 in 1,000,000, compared to 1 in 50,000 for Touch ID. Pause C. Critical infrastructure, such as power grids and water supply systems, is a prime target for cyber attacks. The industrial cybersecurity firm Dragos uses AI to safeguard these vital systems. By analyzing data from industrial control systems networks, Dragos's AI platform identifies anomalies and potential threats, enabling timely interventions. During an attempted cyber attack on a major power utility, the Dragos AI system detected unusual activity and promptly triggered a response, preventing a potentially catastrophic disruption. What challenges do AI-driven cybersecurity solutions face in protecting critical infrastructure? Critical infrastructure systems are complex and often operate in environments with limited connectivity, making real-time data analysis challenging. However, AI's ability to process and analyze data quickly and accurately provides a robust defense against such threats. The integration of AI in cybersecurity also brings to the forefront important ethical and privacy considerations. AI-driven surveillance and monitoring systems, while enhancing security, can potentially infringe on individual privacy rights. How can organizations balance the benefits of AI in cybersecurity with the need to protect user privacy? Implementing robust data protection measures and ensuring transparency in the use of AI technologies are crucial. Organizations must adhere to ethical guidelines to prevent misuse and ensure fair and unbiased AI-driven decisions. In conclusion, the diverse applications of AI in cybersecurity underscore its transformative potential. From detecting fraud and phishing attempts to preventing malware infections and safeguarding critical infrastructure, AI-driven solutions offer unparalleled capabilities. However, the successful integration of AI in cybersecurity requires a balanced approach that considers ethical implications and privacy concerns. By adopting AI technologies thoughtfully, organizations can significantly enhance their cybersecurity measures, ensuring a more secure digital landscape.